benefits and challenges in implementing smart manufacturing, as we are in the era of Industry 4.0, and Industry 5.0 is already knocking the door to see and implement the technologies in manufacturing. All right, so I am Sagar Nikam. I'm working as a lecturer here in the Ulster University. I've been, as I told me about my brief research area, I've been working in the field of additive manufacturing, AI, and computer vision for last few years. So that is where my interest in smart manufacturing came up, and I thought of my diverting my research direction towards in that particular direction. So in today's presentation, where we're talking about, or we're listening about life cycle management. So this was the first what do you say, the ringing bell of where the smart manufacturing was came into existence. Smart manufacturing started evolving. So initially, in previous in traditional manufacturing, once the product was manufactured and sold, there was no backtrack of the particular product, like where is the product, what happened to the product, whether the product is still being used or it's been scrapped. Okay, so that the life cycle information of the particular product was not available. But as we due to environmental impacts or sustainability, as the technology progressing, so life cycle was the first important point where the smart manufacturing started evolving. And later on, like it was the the different add-on advantages of making the manufacturing processes smart. So the next we'll look on is smart manufacturing. Then it's about the technologies that are associated in smart manufacturing. Although we are talking about smart manufacturing, still there are a lot of challenges in it, and we're going to look at those challenges, how those challenges can be addressed. And I will talk about a slide on future trends. There is a small case study of some of the small scale industry which have adopted smart manufacturing, and then the final conclusion. So when we talk about the lifecycle management in the traditional manufacturing and the smart manufacturing, you can see the figure on the screen. So left one is the traditional manufacturing, where you can see a lot of different aspects like order to cash or assets or supply chain, or it could be product. They're all broken in different chain or different cycles. So there was an integration between them. The reason behind this was the lack of the developments in the sensors, lack of development in the technology that can help us to get some informed decision. Okay, so and this, if you look at the figure on the right side, that is a smart manufacturing. So where the smart operations, so all the manufacturing process that takes place in the traditional manufacturing was made smart. Smart in the sense like they were able to make their decisions. They were due to advancement in the sensors. They were able to take their own decisions. They were able to take some. They were able to optimize the process, and this not only helped the businesses, but it also helped the customers, and also it also helped to the ecosystem, like in case of like managing the product or managing the environmental aspects. All right, so when we talk about the traditional manufacturing, we always think of okay, traditional manufacturing processes. So in smart manufacturing, is we just make that particular the machines or the processes smarter by making them real time. So this real time aspect is the most important aspect in smart manufacturing. So that is the reason we say it's smart. Initially or previously in traditional, we were not able to do most of the activities in real time, or there was, for example, if manufacturing is done, we were not able to monitor that particular processes in real time, because lack of sensor abilities or lack of technological advancement. But in the case as we are progressing with this sensors and all those things, smart manufacturing, or what do you say, the operations manufacturers can be now monitored in real time. So this real time is the big aspect that helped the manufacturing processes to become a smarter. So now when we talk about smart manufacturing, so before diving into its technology, what actually is smart manufacturing, let's actually look at its definition, what the smart manufacturing it means. So here the smart manufacturing is like an integrated interoperable, data-driven way of running the value chain. It could be like from sensors and machines to the ERPs. So when the analytics and automation continuously optimize, this lead to the safety, quality, uh, increase the profitability, and along with that, it leads to the sustainability and reducing of the downtime. So when we talk about smart manufacturing, so we need to think of like digital nervous system of the factory. So we look at its digital aspect, where the signals are coming as an input and output are like a decision, and this thing all follow in like a closed loop control. Okay, so signal comes and decisions are sent out, and accordingly the processes are controlled. So this is like a closed loop control system there. So there are three main pillars of smart manufacturing. So one pillar is of data analytics. So obviously, when we are talking about smart manufacturing or informed decision, data is the important part because it allows the manufacturer to optimize the production process. So manufacturers are manufacturing the products in for many decades, okay, but they don't realize that how their own data can be helpful to optimize the production process. Okay, so that is where this smart manufacturing helps to realize the manufacturers how their own data can help to improvise their own process. It can also reduce the downtime, and it can also help them forecast the demands. And while doing this, it should be done in real time data collection. So everything is real time. So that is what makes the process smart. The next thing is the IoT integration. IoT is like Internet of Things. So making the forever devices or the manufacturing process suitable to share the data. So like there is a question like how the machines will share the data to a particular devices or to the team who can analyze the data, right? So in that case, the IoTs were very or the fixing the internet devices on the physical devices were like quite beneficial to share the data without any kind of a connectivity, or like with I would say like a wireless connectivity. So this helps to like seamless communication, and although like communication, but like it's monitoring performance and help to do a predictive maintenance of the system there. The third pillar is like the automation tool. Automation tool, it's not this is not a new one. Like it's been used for many ages. Like we have like CNC machine. CNC machine itself is like an automated machine, or like we call it robots. Okay, so obviously there are different advancement in those technology, but automation tools are running from like very decades there, where the automation helps the manufacturer to implement these other pillars, that's data analytics and IoT integration. So this is all about the smart manufacturing. So when we talk about like what is actually IoT integrated automation tool, so I'm going to just run a small video. So our robotics lab here has some sort of like a uh, uh, some two communication between two robots here. So these are like a pick and place robot which picks the pallet from one location, and then it moves the pallet to the location. Then the one robot communicate to the robot to pick the other pallets there. So like the other robot will come and pick up that the row pallets and move to the final location. So this is what one of the how the IoT is helping the or integrating automation tool. So now it's going to this particular robot one is going to keep the pallets on the location. Yeah, so once the task is completed, robot one will tell the robot two to come and pick the other pallets there. So this is like to just communicate between the two robots, which helps to move the pallets from one place to other place. So now this robot will come and pick up the pallet and put it on his own desk and then move at the other location. Right. So this is how you can see the IoT, Internet of Things, can be integrated with the automation tools to perform the task. So when we talk about the technology, it's not just one technology that makes the particular manufacturing process smarter. So there are several technologies integrated together, which make this particular process or manufacturing process smarter. So one is like we call it as industrial IoT, Internet of Things. So one, if we are mounting any kind of the internet device on any industrial based object or physical machines in the industry, so we call it as like industrial IoTs. Or it could be like autonomous robots, where the robots are enabling the smart factories to achieve its agility and the speed. Then the another emerging technology is like AI, artificial intelligence, machine learning, which is helping to analyze the data and taking the informed decision out of that data there. The cloud computing is actually enables all previous aspects, whether it could be like IoT, AI, machine learning. Cloud computing, it helps to store your AI models, or IoT networks can access that data and perform the task accordingly. Other technology is digital twin. Digital twin is still not, it's still evolving. Many of the manufacturing industries do prefer digital twin. Uh, and the next technologies division is in cybersecurity. Cybersecurity means obviously it's going to be common, because wherever there is internet, wherever there is wireless communication, highly possible that there could be the cyber threats. And if there is cyber threat, then this issue of cybersecurity will come in, and to consider this also as what a part of the smart manufacturing technology. The blockchain is actually, it helps you for real time monitoring. It helps to understand or trace the product's origin. It can also it can also enable the real time manufacturing the customers. Previously, uh, customers, like for example, if you place an order, the industry, let's say, it should manufacture the particular part, and then the particular part was shipped to the customer, back to the customer. Customer were not able to trace the particular part in real time. Real time is like, if I want to see where the product now, so blockchain is actually the most important element which helps you to do that. Then there's edge computing, which helps, which is like a real time pivoting between the blockchain and AI, machine learning. And obviously 3D printing, additive manufacturing, we call it as. And there is a big data which helps you to put technology in the smart manufacturing. So when I talk about this technology, there are certain groups been divided according to the Organization of Internet Standards. We call it the ISO. So ISO has divided this technology in two parts. One is like enablers and enhancers. Enablers are one are mature enough to support the manufacturing processes or make the manufacturing. Enhancers are those which are still evolving. Evolving means under development, we can say. So in the enablers, as I said before, IoT, then artificial intelligence, then cloud computing, precision manufacturing, additive manufacturing, then augmented reality is one of those. Uh, has been quietly supportive in smart manufacturing, robotics, blockchain, or industrial security, or we call it as like a cyber security. So these are completely mature, and they are currently supporting the smart manufacturing. Another enhancers like still under development, but that would lead to the next development of manufacturing, that with through like industry 5.0, we call that like digital twin or digital thread, or we call it like the reference modeling, decentralization, modelization, verticalization, vertical integrations within the company, horizontal integration within the company, product transferences. Okay, so these are all division of technologies that are essential to make the particular manufacturing process 100% successful. So when we try to integrate these technologies, obviously this is going to have some effect on the manufacturing. So One is like effect is like not about like bad effect, but this is going to have like this is going to take the manufacturing at the next level, where where the manufacturers can do or derive that particular business model based on the data. Where the manufacturer can also look at the circular manufacturing. Circular manufacturing, the product life cycle that we call it is, okay, so where is your current product? What was the current state? It's been scrapped or it's been is sent for recycle. All these things come to circular manufacturing. Then the model-based manufacturing, then it could be like a fully automated manufacturing. Then product personalization due to the additive manufacturing, where we can do for like, for example, manufacture the customer a customized product. Already like it's been doing in like biomedical implants manufacturing, so it's like customized implant manufacturing are done. Then it's predictive maintenance. So this is another approach where the predictive maintenance is evolving. It align bit more on digital twin. So predictive maintenance is like usually have preventive maintenance, which is most of the industries follow, but this predictive maintenance is really helping the industries to do the to avoid the unnecessary maintenance activities. Then edge computing, and the one other important aspect is servitization. Servitization is rather than offering a final product, offer a service. Like for example, you see this particular approach has been already implemented by the Rolls-Royce. So Rolls-Royce manufacture the aircraft engine. They give engines to Boeing and also Airbus, but they don't give this particular engine as a product. Like they don't sell engine to the Boeing, or there are other offer service. Like for example, they give this particular engine, and let's say for example, they charge based on the number of hours, like flight hours or 2,000 flight hours. Based on the flight hours, how much engine is being used, the industry will or the charge the particular manufacturer, aircraft manufacturers. The benefit of this is the Boeing will be having fully control of their engines, where so track the engines, like what is happening, where when there can be maintenance or what's been done. So they can track each and every part of within the engine. So that helps to keep the particular product and also protect their own IP within themselves. So that's like the servitization. Many of them are doing nowadays, like electric EV manufacturing. The Tesla is coming up with this same model, offering some services rather than giving the fully product what do you say the ownership to uh, the customers. So if you took of overall, if you look at the key components of smart manufacturing, so this is how it looks like. So the IoT is an important for data collection, for real-time monitoring. Automation is also important, because to integrate the data and IoTs to the automation is very important. By we need robotics to improve the efficiency and productivity. Data analytics is another important tool, where you can see data are captured and information the data has been taken out, and cyber security. So these are the four key components in the smart manufacturing, which helps the particular manufacturing process to be smarter. And Industry 4.0 is all the main pillar of this particular smart manufacturing, which connects the customers, which connects supply chain, which connects every element within the factory to make the particular process smarter. So when we talk about the importance of smart manufacturing, we talk the first importance is efficiency. Obviously, when we are doing everything in real time, we can monitor the process in real time, we can process real time. So that this not only improves the efficiency, but it also gives a lot of flexibility in manufacturing a particular product. The next importance is quality. The quality is going to get improved. Obviously, when you are going to monitor the things in real time, you can control the real aspects in real time. Quality is going to be improved there. The flexibility, one can manufacture the product according to customers' need. The cost reduction. So if you're talking about the predictive maintenance, if you're talking about like manufacturing to the customer's demand, or so in that case, there will be like a less operational cost, could lead to the cost reduction. And innovation. So innovation is going to go on continuously increasing in this field once the IoT and AI is coming in the field. Obviously, now we have technology, okay, IoT and all those things. We have technology, but still deployment of this technology on the manufacturing challenging, or it's important. So in that case, innovation is the fifth aspect. And the sixth which is very important, sustainability. So that's going to reduce the environmental impact and also energy consumption. So when we talk about the challenge of smart manufacturing, the first most challenge is data silos, a lot of data. So it's not about just like, okay, if you produce the data and if you're going to monitor in real time, it's going to produce the data in terabytes, more than terabytes. So management of this data, so there's going to be a data, a big a streamline of data there. And it's not possible, or there's not everyone true that every data is a good, some is bad. So we need to be, we need as an engineers, so we need some skills in this who can assess the data and manage the data. Obviously, the cyber security risk. The third challenge is like skill gap. So as we are moving towards the higher technology, that is not necessary that we need to have a skilled workforce to adopt or to work on these advanced technologies. Then integration of the complexity. So obviously it's not possible. We are not going to do remove all old machines and put the new machines there. No, it's not possible that. We are going to just try to make sure that whatever old machines or old processes there, we call it as a legacy systems are there, we're going to make that into modern. How can the old systems can be modernized and make it smarter? And while doing this, obviously it could be a high initial cost. And the next could be like the scalability issues. Scalability issues is like how this particular process is scalable, or will this particular process keep on increasing and not become stable at some point. So when we talk about the first challenge in manufacturing, is the supply chain complexity issues. So supply chain, the big problem in supply chain is the global the suppliers and logistic across the different countries. So when we talk about smart manufacturing, it's not about we're going to sell the products to the local customers. We're going to look for the global market, right? So in that case, this particular issue might come in. Then there could be market availability. Obviously, when we talk about different countries, the demand of different countries, and we need to what do you say, look at those demand and manufacture product according to that demand there. While doing that, that could be supply interruptions, like for example during pandemics, like there was a supply interruption during that. So that could be another complexity. And also the inventory balancing the inventory level so that we can reduce the excess and shortage cost there. The process integration, while doing that, we need to integrate every stage of manufacturing process. So manufacturing process doesn't mean only the machines there. We are as a human beings within the different departments, like we call up design, manufacturing, quality, all of this integration. Then the data management, that's going to be a complex issue, while in the case of the supply chain and collaboration. So when we talk about supply chain, its very first important thing is the data. So initially we need to have the data of supply chain, so for some so that we can get the informed decision out of it. And while getting a data, it's we need to maintain the flow within the data. Okay, it's not, so it shouldn't be, data shouldn't be broken in different parts, and so that you can't uh, find the particular pattern. This is what actually AI machine learning is. So we it should have a clear pattern of some or some situation that's taking place in the particular manufacturing process. And while doing that, you need to assess the risk, and this can be done by using the tools. So tools can be like AI machine learning tools are there. So we need to use that, and that can help you to reduce the complexities in the chain. The other challenge in the smart manufacturing is the quality control and assurance challenges. So that there are four different problems in this. So problem number one is inconsistent quality across different production batches. Obviously, when we try to manufacture that it is possible that there could be different qualities within batches. So that helps to difficulty in maintaining the quality standards, right? And also proper planning of the inventory. The problem two is like insufficient real-time monitoring capabilities. So real-time monitoring means we need a sensors. We need some advanced sensors. It's not possible every time or every sensor is capable, or every sensors can be used for different. So you need different sensor for different aspect. Okay, so we need that much advanced sensor to capture the data. So that insufficient real-time monitoring could lead to the delayed detection of any quality issues and problem in the quality of particular product. The third is the high cost of manual inspection process. So whenever we use the manual inspection, obviously it's going to be a labor intense, and when labor intense is higher, then it could be lead to the higher increased operational cost, and that causes a high cost of manual inspection. The problem for four is the challenges in integrating the quality control system. So obviously, if you're talking about the quality control, so we have to integrate the different aspects of machineries, the qualities standards together. Okay, so our machines should follow the standard, the designated standard. Only then it will able to manufacture the good quality product that is acceptable in international standards, right? So that is where the problem of quality assurance may come in. So for solution for this could be like one, to reduce its manual thing, so we can use automated inspection where the AIs can be used for real-time quality assessment. So in smart manufacturing, you may come across this word real-time everywhere. So unless and until we say real-time, it won't think like it's like a smart manufacturing there. So then the second aspect will be like data analytics. So as we are doing capturing the data, so it is necessary that, as I said before, the industries are manufacturing the product from decades, so, but they don't know the importance of their own data. They capture the data from decades, but they don't know how their data is powerful to help them make a good predictive decision for the future elements. And the suppliers quality management. So again, establishing standards between the suppliers, and the fourth one is the skills, the employee training for the developed technology. Another challenge is in cybersecurity threat, uh, the vulnerabilities. So obviously, as I said before, if we talk about internet, we talk about wireless communication, there is going to be the cybersecurity. But we can divide the cybersecurity threats into several aspects. So like it could be like a threat could be minor, moderate, a major, or it could be a severe threat. And are like it's likely to be possible. There are some threats are very rare, and some threats are unlikely, means there is a possible of like I say 0.1% chance, but chance, but it's not possible. Like, then another impact could be possible impact. So if you talk about all a phishing attempt, so it's highly possible. Then unauthorized access is highly possible. Then ransomware attacks, data breach. So this is highly possible cybersecurity threats. Some like if you talk about another threats like infected USB drive, so that is like very rare, or a weak password. So nowadays everyone is well aware of the how to keep the strong password. So I know, so that's very rare, or server misconfiguration or industrial control system. And another is like malware infection. It's because of we have like very high end like softwares, and this is very less possible, or it could be like the insider threat or threat within the organization. Then it's possible like there could be like denial of services, like for example, uh, even though we are developing this high-end sensors manufacturing process, it's not possible that everyone can relate to that particular thing. Some may say no for that, like for example particularly small industries, they don't require the small, what do you say, the small elements, so that, or there is possible of like data theft as well, or it's possible of there could be a system failure. Okay, so there are different aspects cybersecurity that can risk the manufacturing aspect. So to improve the cybersecurity measures, so there are main aspects that need to be considered. So one is like the software updates. Always make sure that we are using the latest version of the software. Another is the employee training. So usually like most of the staff, they don't know that what type of or what type of message you get can be a cyber threat. Okay, so like usually, like even in our organizations, we get a regular email, like if we get any kind of attachment, don't open that, because then it particular attachment may consider cyber threat to the organization's internet system. Okay, so that is where the control measures should be taken up. Then the data encryption. So obviously, when we talk about data, it should be encrypted and stored in the protective measure. So even if someone get it or breach it, so they can't decrypt the particular data. The next is about the challenges and integrating the legacy with modern system. Legacy is like the old system, old manufacturing system, or old, or I would rather not say old, but ongoing, current systems within the manufacturing industries. So how can get the modern technology with this old? So it's, as I said before, we're not going to remove the old 100% and bring the new. Okay, if we are going to make, we want to make our old system to modernize it. So we need currently challenging it like as like the assessment. We don't have the assessment strategy or evaluation strategy how the system can incorporate or behave with the modern system. We don't have a proper plan to how can these strategies or how can we seamlessly integrate the old system with the modern system or current system with the modern system. We don't have that much knowledge and understandings to select appropriate technologies that can modernize legacy system, and we don't have that much preparations or execution so that we can integrate the particular modern system with the legacy system. Currently, again, most of the industries are, they claim that they are doing some sort of monitoring aspect, but most of the time, like for example, the as I said before, when we talk about real smart manufacturing, it's real time monitoring is very important in that case. So again, there is a lack of due to the sensors. It's not possible to monitor the data or manufacturing process continuously. Then it's like optimization, and finally, we don't have that much review policies to integrate all these aspects to the modern system. So when we talk about integrating the legacy system with the modern system, there's a practical path to connect our current equipment with the modern IT or systems. So like this process begins with like a business defining business driver. So decide why you are integrating. So it is like OEE, that's overall equipment effectiveness improvement, or you're going to do it for traceability. So traceability is like, for example, you're manufacturing a product and now you want to continue product. Where is my product is, or what's happening to the product, or is a particular product in scrapped or is being recycled. Okay, or it can be like predictive maintenance. So what is the main business driver? uh, the next is the legacy audit. So we all the industry always have the inventory and constraints like PLCs, they have interfaces, protocols. So all these things need to be assessed, so that the decision has to be whether we need to integrate without replacement and replace, or which you can just go on with replacement there. So if the answer is no, then it's like necessary to go to get the restore sensors or upgrade controllers or selectively replace bottlenecks or reassess the feasibility, so we can go back to the loop and understand what is non-disruptive integration, as there is non-disruptive integration is possible. If the decision is yes, then we can go out with the modern edge gateways and protocol conversions, where the bridge modbuses or different cloud computing type of aspects can be taken into consideration. We can also go forward with data modeling and security, the pilot integration. So what I want to say in short is that it is the start with the business to assess the legacy landscape, choose whether we want to retrofit or replace that, and use the gateways and standardized data models to for a pilot, and then scale with the security and observability backed, which is backed in. Another challenge is on the workforce skill gap and training. Actually, I was saying, so we have different people involved in the industry, manufacturer, to run the particular organization. So it's necessary that we need to skill the people in with these advanced technologies, where while doing that, one need to assess the skill, particular training program for that, and develop the produce training material for that, implement the technology, evaluate or measure that particular aspect, and this should be kept revising and sustainable. So this is one of the we can say that like FDP. This FDP could be one of that type of programs which can upskill the what do you say, the employers or the industry people who want to advance in the industry 4.0 or smart manufacturing. Another challenge is like the data management and its analytic difficulties. Although we think about like we have data scientists, but there is a lot of different aspects that need to be considered when we assess the data, or we have when we get an informed decision out of it. So like for example, if you look at the screen here, so let me baseline where we are with the data and analytics. First, when you talk about data hygiene, is our data at the bottleneck? Bottleneck is like, for example, is the data every data element of data important? Okay, or is there some? It's not necessary that every data captured is a good data. Some data can be bad. So that is what we call it data hygiene. So, like for example, in the case of data cleanliness levels, like in this case, it shows that 21%. That means there's a lot of missing values. It's a lot of inconsistent tags, and there is a lot of duplication of the data within the things. So when the data isn't trusted, people can't use it, right? And we see that particular as very soft adoption. So we can't use that particular data in the case of if you want to make some informed decision. So across the pillars, data quality is low and real-time insights are limited. And when the system integration is medium, it's not end-to-end we are moving with. Okay. So when we need to move at some one point or other, we need a continuous change or flow of data within the system, and that helps to improve the efficiency. Okay. So for collecting the data, we need to follow certain steps. So when we look at the strategies, so there's some certain challenges, solutions, the technologies that helps you to collect data and its impact. So there are different aspects that we need to consider in data thing, that is data collection, data analysis, data security, and integration. Okay, so data collection is the first. Once we have data collected, then we analyze it. Once you have data analyzed, you remove differential good and bad data. Then there's data security. Security is another important, that is related to cyber security. So you have to store your data securely, else it's highly possible that it may be uh, a threat to that particular organization if the data gets leaked. And integration, data integration is not you don't have to fix on one data. Once you go ahead in the manufacturing process, so you continuously collect that data and you get added with the previous collected data. So in that case, there are different challenges. And like, for example, if you go with data collection, it's possible we will not get a complete data. We can get incomplete data as well. When we go out with data analysis, it's possible that it's highly complex. So like it's possible, like for example, when we go with image type of data, or when the data is recorded in videos, so in that case, complexity level gets high. If we have a data in numbers in the Excel sheet, in that case, like where data is a bit more easy to assess. Then the challenge of cyber threat, and also data integration with the challenge of getting the soil system. So solution for that is like building an automated system that can collect the data. So like for example, you want to monitor the process, so building a camera system that can continuously monitor the deposition process or the manufacturing process, and it can help to automate the gather the particular data. And then using the AI tools to analyze the data, or making the use of the robust software encrypt the particular data. So this is where like blockchain also can help in, or data integration where the unified platforms are there, where you can where you can keep on integrating the data. Technologies that can be like IoT devices or machine learning, as I said before, like blockchain security, and the integration like cloud computing. All right, so when we talk about the data strategies, so the very first thing is like the efficiency gain. So when you have a good data, efficiency gain is the first important thing that gets affected, or that get help the manufacturing process. Then next comes the cost saving, and the next comes is the quality improvement. Another important challenges in smart manufacturing is the collaboration between the departments. So this is collaboration between the departments is, I think, is not a new one. We're talking this collab between departments right from uh, old days, but it's not possible due to some sort of technological advancements during that time. But as we are using like AI and machine learning, and we have like different communication devices, the collaboration between the departments is possible there. So you can address the collaboration by properly keeping the channel of communication, using the monitoring, proper monitoring system, monitoring the efficiency of the people who are working within the departments. All right, so this is one of the thing you can help in addressing the challenges. I hope I'm not late there. So I'm just going to go on to another challenge there. So the next challenge is the regulatory compliance and challenge. So when we talk about the smarter manufacturing, it's maintaining its regulation is an important thing, right? So when we are doing it, manufacturing process, we are talking about different regions, different countries, different culture. Okay, so in that case, maintaining of the data or maintaining of the regulatory compliance with different thing is very important. Another challenging part is the data. Okay, so every country is having their own rule of maintaining the data, or they have own law for their data. Like India may have like their own law of security data, like in the what do you say, the UK and the Europe, they follow European data protection law, like we call it GDPR. So everyone has their own law. So again, compliance between these laws is a big challenge. So that is where the manufacturing or linking the chains of manufacturing within the worldwide is getting the problem there. So again, we need to then there should be like proper compliances or meetings between the different aspects, so that this compliance on data, standardization of data aspects should be uh, what do you say, they should be set together, and they should need think of building a good regulations so that could benefit the manufacturing industries throughout the world there. The next challenge and this is in smart manufacturing is the sustainability and the environmental concern. The sustainability in the first global impact. So when we talk about the smart manufacturing, we look at its influence on global sustainability. So that the bigger impact will be on the global. The next is resource management. Obviously, when we are going to make the particular process smarter, it can minimize the carbon footprints. So we need to have like on that aspect as well. The energy efficiency is the third more benefited part. The waste minimization, circular economy, the regulatory compliances, the supply chain, and the last part is the employee training. So this is all part of the challenges in the supply sustainability and the environmental concern. So when we want to adopt any kind of a challenge, or if we want to address a sustainability challenge in manufacturing process, the first most to consider is optimizing resources. So real-time monitoring system can help you to optimize the particular process and reduce the waste. Energy efficient is uh, maintaining the energies or maintaining the particular operation of the particular process. Like for example, there was a project I was attending one conference there. So they were trying to working on energy efficiency. So, and the energy efficiency was like, for example, the machine will get switched off when it's idle. Okay, so when the machine will try like it to analyze if it's not idle, if it's a switched off. This is what a computers nowadays, like if you have your advanced computer, if you keep your computer idle for some time, at some point like it will go automatically go in the sleep mode. Okay, so this is like the to just to maintain the energy, to optimize its energy efficiency. Okay, so this is where when it's idle, yeah, it will go in automatic sleep mode or something like that. Then we talk about sustainable materials. which are environment friendly and recyclable. We talk about like best management, the product life cycle, training. So, and if you look, one common element is employee training. It comes in every, what do you say, every aspect. So this is where you can see that in every element there is a lack of skills where currently smart manufacturing is facing. The next challenge is like technological and its adoption. So although we are talking about the technological disruption, smart manufacturing is not a new, okay? It's like coming from many years. Obviously, it's scaling at that high level, but still, the pace at which it's scaling is very low. Like when we start about thinking of smart manufacturing, that was back in 2021. Then there was deployments. Although like IoTs has been studied like before, like I remember 2015 or 2014, but it actually got deployed in 2022. Then integration of AIs. Okay, AI is again not a new thing. It's being like, I think I remember that it's 1985 was the first time where the AI community existed, but it got booming recently. It starts like having a good booming of it. Then optimization, scaling. Okay, so resilience and innovation. So these are the technological disruptions that causes the thing. Another most important challenge is about the availability, sensor availability, and real-time monitoring. So when we talk about smart, making the particular manufacturing process smart means are going to capture the data in real time. So there should be some sort of sensor which should be available to capture the data there. Like for example, if I work in the field of additive manufacturing, so like for example, uh, we have IR cameras that can monitor the deposition process. We have monitor IR cameras that can, or different high dynamic range cameras that look at the deposition process continuously. But when it's this will help us to get the temperature analysis. But when it comes to residual stresses, we don't have any sensors that can do any kind of a real time data acquisition, right? So that the limitation is we can do one part real time, but there is not possible to do other part of the process in real time. So when these two parts will be in real time, then it will help to increase the reliability, or it could improve the efficiency of the manufacturing process there. So that's like the reason the sensor availability because of harsh environment, or lack of calibration, or lack of like sensor lifespan and maintenance. Again, it's the sensors which we have currently has been not that cheaper. Okay, so again, when it comes to maintenance of the sensor, it is like you go for like the large scale industries. The small and medium scale industries have very rare chance of implementing this sensor within themselves. So in case of to address the challenges related to sensor availability and real-time monitoring, so one need to go with the sensor, or we need to develop the sensor that is uh, industry grade. The deployment. So we already have like AI models. We all know that there are AI machine learning. Everybody is using the AI and machine learning, but when it comes to deployment, there is lack of thing there. So we need to think how AI and machine learning or things can be deployed in our manufacturing aspects. Then the use of simulation and digital twins. Okay, simulation is like used from decade, but digital twin is coming existing. So how can we make use of digital twins to improvise the process? So this can address the challenges related to sensor availability and real-time monitoring. So like simulation, like for example, in case of you can't do with the sensors on available to predict residual stresses, so we can build a simulation or digital twin that can help to predict the residual stresses in real time. All right, so this is how we can address the challenges where the sensor is not available. So in any challenges or whatever challenges I told, or any other challenges in the smart manufacturing, so we first need to assess them, that there should be a proper plan for its integration. It should be a proper plan for implementation. That's what we call deployment, and it should be having a review regularly. Okay, so every challenges for successful success, we need to follow these particular steps in the by solving the particular problem or solving challenges in the smart manufacturing. So when we talk about the future trend, so if you look at the SWOT analysis, that is strength, weakness, opportunity, and threats. So the strength is of the smart manufacturing is going to improve the efficiency, it's going to reduce the cost, and it's going to help the businesses grow. The weakness is like it the small firms or small industries or even medium scale industries may not able to adopt this technology because of its cost or lack of resources. And the small industry, like there we don't have many people skilled employers to work there, so it's very difficult to skill the people or employers in the small industries. That could be the weakness there. There's an opportunity where we can improve or deploy the AI models in the actual machine learning or actual manufacturing environment, and make use of the IoTs to capture the data there in the real time. And the threat is about cybersecurity risk, which can disrupt the global supply chain or even the organization manufacturing strength. So in summary, I would just like to take you to some few points. So it's very important to address major issues. Obviously, we are talking about smart manufacturing, but smart manufacturing itself is still emerging and it's not a mature field where every manufacturing industry can adopt it. So we need to address that. So we need to leverage technology where the advanced technological advancement requires, whether it be like a AI technology or whether it's like machine learning technology or whether it could be like a, what do you say, the sensor technology. There should be proper collaboration within the departments, within the people, and the continuous improvements is only key for taking this smart manufacturing as a real. So this is a case study. I'm just going to take you through how smart manufacturing or how the sensors are going to help one of the small industries. So again, as I said before, small industries is they want to implement the technology, but still there is some problems or issues they are facing in. So this case study is like they want to develop the the automated work plan. So where they don't want to rely on the human. Again, it's a threat to human being there. Yeah. So the robot can who want to work 24/7. So there was a momentum manufacturing group in US, and they want to automate the CNC related workflow to meet and achieve the demand in like. So the robot should be like, for example, they should continue to work on the lathe. So lathe machine, the robot should install a part on the lathe. The robot can remove the part on the lathe, and then the robot can go to, it can clean, measure on the part quality, and then the robot can go for packaging. So it's like complete full system where, so the particular the industry like momentum manufacturing group, they develop a proof of concept study where they selected a workflow. Like for example, if you look at the figure on the right, so this is the workflow. There are the four lathe machines which has to be what do you say, managed by a robot here, the more robot here at the center. This is the robot, same robot that I showed it previously in the one of the video. So it's called as enhanced robot, and that is where the robot it helps to communicate between themselves and also pick and place and do different tasks there. So so the manufacturing, the solution they want to do is like they want to run a 24/7 workflow, and they want to use the mobile cobot charges while working there, and they want to eliminate the use of human being to in every aspect of machining there. So currently they were doing it for three workstation, like sorry, four lathe machines, but as of now they currently they have implemented that in the only one lathe machine. I'm going to show that video in next slide there. So and the entire workflow there was completed by the ER ability. So there is the ER which called as the enhanced robot ability. So the particular model of the robot that being used is called ER ability. So recently they have called ER Flex. ER Flex is like one that robot can communicate with themselves. The one that I showed previously, one of the slides. So ER ability is again it can do the workflow, automatic workflow by its own. So just to take, oh my. So I'm going to show this a video of that, how this particular robot is doing that operation. So that they are implementing this on a single lathe machine. So the machines perform the machining task so that the robot will take off the part from that uh, machine. Then it will be like go on cleaning. So a cleaning station where the part will be cleaned from any kind of a some, like, what do you say, the coolant material, coolant oil, or something like that. Then it will go on with the CMM, current measuring machine, to check its quality. Everything is in place, and once its quality is being checked, it will go and packaging. So there is a pick and package pallets where the robot will try to place all the samples in that in the particular pallet box. So this is one of the case study where you can see the small scale industries are where this type of robots are helping the small scale industries to adopt the smart manufacturing technologies. So these are some of the references that I used to prepare my presentation there. Thank you very much for your time and attention. I hope I'm not over time there. If any questions, I'm happy to answer there.
Online participant can write in the chat box for any query. Hello, sir. Myself, Manish Jindal, working in the same metal additive manufacturing domain.
Hello, sir.
So, sir, I want to ask a very basic question, sir. That as you said that during the additive manufacturing, that it is we can't monitor the real-time residual stresses.
Yes, yes.
So, is there any other way that how we can measure the residual stresses during the real-time monitoring apart from?
That is what is then that they make use of the simulation. Then that's the only thing they do. It's like what they do, like they use FEA based simulation, train the model based on FEA, and then predict the residual stresses. And then again, nowadays, like what other come out recent research that they are using AI to predict residual stresses as well. So that's like real time monitoring of the residual stresses through simulation.
And sir, what are the
This,
basic
yeah.
AI or ML software that can be used uh, for measuring or simulate the residual stress?
Uh, one thing is we make use of two approaches here. So one is the initial approach, physics-based learning, where we use ANSYS. ANSYS helps we in the first stage we predict the result stresses for different combination process parameters. There we build a data set for that. One, we have images for different time step. Then we capture that images, and there is a GAN process of AI process. The GAN is another element which helps you to predict the future frames. Like for example, I simulate for first few seconds, and then after that second, the GAN will help what will be residual after that. So this is what we do in integrating both physics and the GAN-based analysis. There, we call that GAE, generative AI. We use that.
Thank you, sir. Thanks a lot, sir. We have a one query in the chat box. So the
Yeah.
query is, what specific strategy can small and medium-sized enterprise adopt to overcome the challenges of implementing smart manufacturing technologies?
The very first important is the cost. So even though like sensors are advancing and all those things, but we don't have that much cost-effective solution for small scale industries where they can adopt it or they can implement in that industry. So that is where the small or medium scale industries are facing with. As I said before, like small scale industries, they have very few employees, like we can say tens, hundreds. We don't have that much kind of what do you say, workforce who can skilled workforce who can manage and control these aspects. So that are where I see the problems in small and medium industries currently facing in.
And so there we have another question, and saying, could you please elaborate on digital twin and digital threads? What is the basic difference?
Yeah.
What are that?
Digital twin is, like for example, it's a virtual replica of actual process. Okay. And like for example, if you are monitoring tomorrow, I will be delivering one of the session on digital twin, that's CPS and digital twin. So what is happening, like virtual replica of the process or machine, we call it a digital thread. And if we connect it with different aspect, like for example, I have one machine in UK, but the same machine is in one in your MNIT Jaipur there. So how can we connect that so to the digital way? So that's called a digital thread. So that is again the new aspect coming in.
Thank you, sir. Thanks a lot, sir. We have this faculty development program coordinators, Dr. Jinesh Kumar Jain, sir, and Dr. Yashwant.
Hello, sir.
Hello.
Yeah, I know, like you submitted that particular proposal.
Yes, we have
recently.
submitted it, sir.
Yeah.
We have submitted it, and he's Yashwant. He's the also
sir.
with us in this project.
Hello, sir. Hello.
So I'm
Hello, sir.
here assistant professor at MNIT mechanical department. So my friend of friend is Janoop sir. So he gave your reference.
All right. Oh, right. Juniper, I've been like, in touch with for a long time. Yeah, it's nice meeting you, Shwant. So, yeah.
Thank you.
Thank you very much.
Tomorrow we will be again meeting, sir. Right?
Yeah. Thank you very much, Jinesh, sir. Thank you.
Okay.
Thank you, sir. Thanks a lot.
All right, thank you. So tomorrow at the same time, I think. Same
Yes,
time we are going
same,
to.
same time.
Same.
All right. Thank you very much, guys, for this. So we'll meet tomorrow again.
Yes.
Yeah.
Okay.
Okay, sir.
Participant, we
Bye-bye.
may continue the session after the lunch at 2 o'clock. Thank you.
तो ये बोल रहा है कि सेशन स्टार्ट करके चले क्या?
Start.
क्योंकि आधे घंटे में हम आ तो नहीं पाएंगे.
मेरा तो उधर गया क्लास है. मुझे क्लास
तो आप सर के साथ में चले जाओ, मैं 2 बजे के बाद में चला जाऊंगा.
ठीक.
ठीक.
तो मैं आऊंगा तो स्टार्ट कैसे करेंगे? तुम स्टार्ट कर देना, तुम निकल जाना.
जब आप आ जाओगे, जब
हाँ.
तक फिर हम
मैं बैठा रहूंगा.